How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss parallelograms. In this video, you will learn the different properties of a parallelogram as well as apply these properties in solving problems involving parallelograms. But before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners, welcome to another session here in Math Learning with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for quarter 3 of the grade 9 mathematics, which is all about parallelograms. The first question is, what is a parallelogram? Parallelogram is a quadrilateral in which its opposite sides are parallel. Now, the next question is, what are the properties of a parallelogram? There are 6 properties of a parallelogram. Property number 1 says that in a parallelogram, opposite sides are parallel. That is by its definition. Property number 2 says that in a parallelogram, opposite sides are congruent. Example of that is this figure. Okay, now let's go to property number 3. Property number 3 states that in a parallelogram, opposite angles are congruent. Example of that is this figure. Now, let's go to property number 4. Property number 4 of a parallelogram states that consecutive angles of a parallelogram are supplementary, meaning that the sum of 2 consecutive angles will always be equal to 180 degrees. Example of that is this figure. Easy, right? Now, let's go to the property number 5. Property number 5 of the parallelogram states that in a parallelogram, diagonals bisect each other, meaning that in this quadrilateral, the 2 diagonals will be meeting in their midpoints. Example of that is this figure. Now, let's go to the last but not the least property, and that is property number 6. Property number 6 states that in a parallelogram, each diagonal cuts the parallelogram into congruent triangles. Now, for you to know more about the different properties of a parallelogram and understand it deeply, let's go to our discussion board. Okay, math learners, we are here in our first problem. We have the parallelogram LOVE or L-O-V-E. As you can see in this parallelogram, we have the given algebraic expressions as its sides. Now, the question is, what are the values of x, y, line segment LO, line segment EV, line segment LE, and line segment OV. Now remember, my dear math learners, the second property of the parallelogram, and that is the opposite sides of a parallelogram are congruent, meaning this line segment and this line segment are equal, and this line segment and this line segment are equal. Therefore, we can say that LO, line segment LO, is congruent to line segment EV, while line segment OV is also congruent to line segment LE. Okay, now for us to solve these values of x and y, what we need to do is to equate the given expressions. So LO is given as 2x plus 9 is equal to 8x minus 3. So for us to solve this, we need to apply what we learned in algebra. So we will combine like terms. Therefore, we will transpose our 8x to the other side, giving us 2x minus 8x. And we will transpose our positive 9 to the other side, which will give us negative 3, because that is minus 3, minus 9. Easy, right? So now, let's simplify. 2x minus 8x, that will give us negative 6x. And negative 3 minus 9 will give us negative 12. We will divide both sides by negative 6. So this will be cancelled. And our value for x is positive 2. The value of our x is equal to 2. Easy, right? So having that said, if we will try to substitute the value of 2 in our given expression, we have 8 times 2, that is 16. 16 minus 3, and that will give us 13 units. Of course, because of the property, this is also 13 units. Now, if you want to make sure, you can also substitute the value of x, which is 2, to the 2x plus 9, and that will give you 2 times 2, that is 4, 4 plus 9, and that is 13. So the same 13 units, 13 units. So we already have answered the measurement of line segment LO and the measurement of line segment EV, as well as the value of our x. Now, how about the value of our y and the two remaining line segments? So we have here the relationship OV is congruent to LE. So our OV has the expression y plus 5, while our LE, line segment LE, has the expression 3y minus 5. So what we can do here is we just simplify. So the same concept, we will apply what we have learned in algebra, combining like terms, and this will become y minus 3y is equal to negative 5 minus 5. 3y, when transposed, this will become negative. Positive 5, when transposed, it will become minus 5. Easy, right? Okay, so y minus 3y, that will give us negative 2y, and negative 5 minus 5, that will give us negative 10. We divide both sides by negative 2. This will be cancelled, giving us the value of y, and this will also be cancelled. So 10 divided by 2, that is positive 5. Therefore, the value of our y is equal to positive 5. Now, for us to know the values of our line segments, we will just substitute it. So positive 5, 5 plus 5, that is equal to 10. Of course, by the concept of the property, number 2 of the parallelogram, opposite sides are congruent. So this is also 10 units. Now, if you want to make sure, use this one. 3 times 5, that is 15. 15 minus 5, and that is also equal to 10. So you have answered this problem. Easy, right? Now, let us go to our second problem. Okay, math learners, we are now to our second problem. We have here the parallelogram kind. So we have K, I, and D. Question is, what are the value of x, the value of y, as well as the actual value of angle K, angle I, angle N, and angle D? Okay, now, how do we solve this one? In order for us to solve this one, my dear math learners, we need to apply the property number 3 and number 4 of the parallelogram. What are those? In a parallelogram, opposite angles are congruent. And in a parallelogram, consecutive angles are supplementary. Now, how do we apply that in our problem? Now, as we can see, angle N and angle I are consecutive angles. So, therefore, they are supplementary. So, if we add angle N plus angle I, the equal of that one is 180 degrees. So, we will be talking about the measurement of angle N and angle I. Okay. Now, by applying the property number 3, opposite sides are congruent, we have also the idea that angle N and angle K are equal. So, angle N is congruent to angle K. Now, how do we solve this one? Now, let us try first to substitute our given expressions. So, our angle N is 135 degrees plus our angle I, that is 3x, is equal to 180 degrees. While in the angle N, we have 135 degrees is equal to our angle K, that is 2x plus y. Now, my dear math learners, where do you think among these two equations need to solve first? Okay. Now, as you can see in the second equation, we have two variables unknown. While in the first equation, we have only one variable. So, my dear math learners, I'll give you a tip. Always solve first with the problem that has only one variable. Okay. So, we will start it with this one. Okay. So, having that said, we will just apply what we have learned in algebra. We will transpose like terms. So, we have 3x is equal to 180 minus 135 degrees. By simplifying, we have 3x is equal to 45 degrees because 180 minus 135 is 45 degrees. In order for us to solve for the value of x, we divide both sides by 3 and we have the value 15 degrees for our x. Okay, but that only answered this problem. Now, how do we solve for the measurement of angle I? So, since angle I here is 3x, that means 3x is equal to 15 times 3, and that is 45 degrees. So, we have the value here as 45 degrees. Easy, right, my dear math learners? So, we already have answered the angle N because that is given. And our angle I is also given. So, that is 45 degrees. Of course, by applying property number 2, opposite angles are congruent. So, angle I and angle D are equal. Therefore, we can also say that angle D here is equal to 45 degrees. Of course, we can also know that since this is angle N, our angle K is also 135 degrees. Easy, right? Because of this given. But the question is, how do we solve for the value of our y? Okay, so in solving for the value of our y, we will apply our x here to our expression here. So giving that is 135 is equal to 2. Our x is 15, so that is 15 plus y. So in this manner, we only have one variable. So that is 135 is equal to 30 plus y. Then we transpose our 30. So what is that? That will become minus 30. And 135 minus 30, that will give us 105. So that will be the value of our y variable. So we have answered our x, our y, and all of our 4 angles. Easy, right? Now, let us go to our third example. Okay, my dear math learners, we are down to our third example. And this is a parallelogram with diagonals in it. So we have the parallelogram SAVE, S-A-V-E, in which the diagonals intersect at point R. Okay, so these are the problems that we have. What is the measurement of line segment RE? So this is the one. If our AR is equal to 18. So, my dear math learners, this is the unknown, but the given is this one. Okay, remember, my dear math learners, in the property number 5. And what is that? In a parallelogram, diagonals bisect each other. So, since the two diagonals intersect with each other, they also bisect each other. What do we mean by that? It means that it cuts each diagonal into two congruent parts. So, meaning this measurement is also equal to this measurement, as well as this measurement is also equal to this measurement. So, without solving, since this is given as 18 units, therefore, this is also 18 units. So, therefore, our RE is equal to 18 units. Easy, right? So, the next problem is, what is the measurement of line segment SV? This is the whole diagonal. If your RV is equal to 6. So, if this is 6, my dear math learners, of course, this is also 6. But the unknown is the whole given. So, therefore, we can say that SV is just equal as RV plus SR. So, the line segment SV is just equal, since RV is given, and RV and SR, the line segments RV and SR, are congruent. Therefore, SV is equal to 12 units. Of course, you can solve it without using any solution. By just looking at it, you can have the idea. Easy, right? Okay, my dear math learners, let us go to our third part of the third problem. That is, what is the measurement of line segment RA if the line segment RE is x plus 10 and the line segment AE is 3x minus 5. Okay. So, remember, my dear math learners, that AE here is the whole diagonal. Of course, we can say that AE is equal to RA plus RE. Right? Okay. So, Since AE is given with the expression 3x minus 5, and RA is also given, or not yet, and RA is not given, however, RE is given as x plus 10, remember that this one and this one are equal, right? So we can say that RA is also x plus 10. Somehow, that is also the expression of RE. So we have 2x plus 10. Okay, now my dear math learners, we need to simplify this one, and we will have 3x minus 5 is equal to x plus x. We have 2x, and this will become 10 plus 10, that is 20. By simplifying, combining like terms, we have 3x minus 2x equals 20 plus 5. So 3x minus 2x, that is x. 20 plus 5, that is 25. So this is the value of our x. But that doesn't answer the value of our RA. So what we will do is we simplify the value of x to our given expression, x plus 10. So since RE is x plus 10, that is 25 plus 10. This will become 35 units because that is RE. Of course, if this is 35, this will also be 35 units. And if you want to get the total value of the whole diagonal, you just add them, and your AE is equal to 70 units. So therefore, if we just answer the problem, what is the measurement of line segment RA? That is 35 units. Of course, we have also solved the values of the line segment RE and the line segment AE. Easy, right? Now, let us go to our final problem. Okay, my dear math learners, we are down to our final example, and we have the parallelogram GOES, or GOES. So that is GOES, and we have one diagonal that is being made, and we have some angles. Now, the problem is, what is the measurement of x, or what are the values of x, y, the measurement of angle GSO, and the measurement of angle ESO. So this is ESO. Okay. Now, my dear math learners, remember the last property of parallelogram, and that is, in a parallelogram, each diagonal cuts the parallelogram into two congruent triangles. So as you can see, this is one diagonal. So by this one diagonal, we have formed two triangles. And these two triangles are congruent based on our property. So, by that definition, we also have the idea that this 58 here and this 4x plus 10 there is congruent. Why is that so? Because they are alternate interior angles. If you still remember your lesson in a parallel lines cut by a transversal, that is a relationship of this kind of scenario. Okay, so by this idea, my dear math learners, we can say that angle GOS, this is the one, is equal or congruent to our angle ESO. By that idea, we have the expression 58 degrees is equal to 4x plus 10. Easy, right? So now, let us solve our value of x. So, this is 58 minus 10 is equal to 4x because I transpose the plus 10 from the other side, giving me 48 is equal to 4x. I divide both sides by 4 in order for me to cancel the 4 here, and I'll just have the value of x. 48 divided by 4, and that is 12. Therefore, the value of my x is 12. Of course, by applying the relationship of alternate interior angles are congruent, or even by just looking at this angle 4x plus 10 is also equal to 58 degrees. Why is that so? Let's just try to substitute the value of x. 12 times 4, that is 48. 48 plus 10, that is 58. Easy, right? Now, having said that, we can also say that our angle EOS is also congruent, this is the one, to our angle GSO. Of course, we can say that this angle is equal to 64. But the question is, what is the value of our y? Now, by doing that, we can use the given expressions and the given values. So we have 64 is equal to 4y. Dividing both sides by 4, we will have the value of y as 16 because 16 times 4 is 64. Okay? So therefore, we have the values of our y, our x, and the other measurements of our angles. And that, my dear math learners, is how we apply the properties of parallelogram in solving problems involving parallelograms. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, my dear math learners, I hope you have a wonderful time on this discussion about parallelograms. This is still your free access math teacher Ash. And if you do have some questions, inquiries about this topic, feel free to put your comments or your inquiries in our comments section below. Always remember, it is fun to learn mathematics if we are together learning. Thank you so much, God bless, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.